Assalamualaikum warahmatullahi wabarakatuh. My name is Nabila Sawia from EC104B. For today practical test of ECS268, I'm gonna be talking about the 3-hinge arc experiment. So for the objective of this experiment, it is to determine the reaction of 3-hinge arc due to the applied load of point load and uniformly distributed load. For the procedure, first we need to set up the 3-hinge arc apparatus. Then we measure the length span, which will be noted down as L from the support A to support B. Next, we measure the height of rise, which is R, from the heel lines to the crown. After that, we recorded both of the measurement down. Next, we started to measure the length between the support A to the first point load, and then we measure it to the second point load until the last load. Next, we have to make sure that our reading indicator is 0. We can just press the tar button to make it 0, and we wait for a few minutes. But if there's still So we divided this test into two, which is point load test and uniformly distributed test. For point load test, we have to use at least like a weight which is like 2 Newton weight, and we put it on the load hanger, and we just read the reading and recorded it. After that, we do it the same thing to the second point load. Use the same weight and until the last point. After we have recorded it all, we use the second weight, which is 5 Newton. Use the same step as we may take the reading of the first weight, which is 2 Newton, and recorded it down to. After we have finished recording the reading measurement from the indicator, we then continue to conducted the uniformly distributed load. So first, we have to take the UDL load, which is usually 25 Newton, the first one, and we put it at the center of the span. We make sure it at the center, as we do not want to make any error. As you put at the span, we just take the reading. After we have recorded the reading, we add more load onto the span. First, we use the 25 Newton, 50 Newton, and finally 75 Newton, and we noted it all down into the table. So for results or data and analysis, we will have to fill in completely all the table, the point load table and the uniformly distributed load. The first column of the point load table is the distance from A to the load hanger or to the point and continuously. Then we just take the experimental value of the horizontal reaction, and we note it down based on the load, which is 2 Newton and 5 Newton until the end. For the point load, we actually have to calculate it theoretically. So we use the formula, which is we have two sections, is left side and right side. So for the left side, the formula is horizontal reaction at A equal to W indicating the load, which is 2 Newton for the 2 Newton load. W times with X represent the distance from A to the first load hanger, and this is based on their distance, the distance from A, and then we divided W times with X with 2R. R is the rise. After the total point in the 3-hinge arc cable is usually 7, so we can distribute it into, like, for the left hand side we can use 1 until 4, and for the right hand side we use 5 and 7. So for the formula for the right hand side, horizontal reaction equal to W, the weight, times we have to put in bracket L, which is the total span of the beam, minus with the X, and divided by 2R, and we will get the horizontal reaction. However, it is different for the uniformly distributed load. We actually still need to calculate the theoretical value, but the difference is the formula, of course. The formula for the uniformly distributed load is horizontal reaction equal to W, the load, times with the L square, which is the span of the beam, divided by 8R. R is the rise. After we have calculated all of the theoretical value, we just put it in the table to compare between the experimental value and the theoretical value. Then we calculate the percentage difference between the experimental value and theoretical value, which is basically the different percentage equal to experimental value minus theoretical value divided by theoretical value times with 100%, with 100, to get the answer in percentage. After that, we actually have to plot a graph just to show the difference between the experimental value and theoretical value. For the discussion, we found that from this experiment, when the rise of the arc increases, the horizontal reaction of the 3-hinge arc decreases. This is due to the result of maintaining the arc action. Thus, the external vaccine must be employed or involved. The result of the graph is a linear graph of directly proportional. From the graph that we have plotted, we found that the relationship between the horizontal reaction at the support and the applied load is directly proportional. Thus, as the applied load increases, the horizontal reaction will also increase. We also found from the percentage error that we have calculated, we also found that the experimental value and theoretical value is not the same and have a little bit difference. This is due to the error that might occur. This is due to the error that might occur when we conducted the experiment, such as the human error. To prevent this error from happening, we should at least recorded the reading or repeat the experiment 1 or 2 times to make sure that it is accurate. The error might also occur if the digital display of reading is not set to 0, and thus will affect the experimental value.